Hello everyone. Today I would like to discuss about the normal distribution of a data. In a sample data, we can actually conduct it to different types of tests. One is parametric test and another is non-parametric test. In order to conduct a parametric test, our data should be normally distributed because this normal distribution is the prerequisites for different types of statistical tests like correlation, regression, t-test and analysis of variance. If our data are not normally distributed, so the resultant mean will not be a representative value of our data, and a wrong selection of the representative value of a data set and the further calculated significant level using this representative value might give a wrong interpretation of our results. That is why first we test the normality of the data and then we decide whether the mean is applicable as a representative value of the data or not. So for the testing the normality of the data, there are basically two broad methods. One is the graphical method and another is statistical or numerical method. For graphical method, we have the histogram or box plot. We can use the QQ plot or we can use the PQ plot. And for statistical or the numerical method, we can use the skewness or kurtosis of the data. We can use the Kolmogorov and Shimnov test, and we can use the Shapiro Wilk test. So among all of these tests, most commonly and most effective tests are the Shapiro Wilk test and the Kolmogorov-Shimnov test. So today in this video I will actually discuss about these two tests in details, how to conduct this test. In Shapiro Wilk test and Kolmogorov-Shimnov test, the Shapiro Wilk test is more appropriate method for the small sample size when the sample size is less than 50, but it can also be applied on a larger sample size also. And the Kolmogorov-Shimnov test is basically used for when the sample size is more than 50. And for both of these tests, our null hypothesis will be that the data are taken from a normal distributed population, and after the analysis, if the p-value is greater than 0.05, so the null hypothesis will be accepted and the data are called as a normal distributed data. To test normality, so now I will show you how to test the normality of a data using the SPSS software. So here you see that I have two variable 1 and variable 2. So after copying the data from the Excel, I pasted the data in the SPSS software in the data view. In the variable view, here you see that here I have two variable 1 and variable 2, and the type of the variables are numeric, and all of this will remain same, like the width and decimal values and missing values, and so the measure will be changed as these are the numeric types of data, so the measures will be a scale and the measures will be a scale. So now I'll go to my data view and go to the analyze. From the analyze, you have to go to the descriptive statistics, and from the descriptive statistics you have to go to explore. So from here, these two are our dependent variable. So from here I go to the dependent list and this one put in the dependent list, and for options it will be continue. For plots, I don't want the stem and leaf, so uncheck this box. I want the histogram. For box plot, I don't want them. I want the normality plots with the test and continue. And for the statistics, maybe I want to check the descriptives, okay, and then continue and then press OK. And here is your results. You see the first table actually is not our business. Here is the descriptives of my two variable. Here's the mean. Here is the mean of the second variable, but I am more interested about the test of normality. You see here our variable 1 in Shapiro Wilk test, our variable 1 has a highly significant, that means, and variable 2 is non-significant. So this highly significant means we cannot reject the null hypothesis. That means the data is not normally distributed for the variable 1, and for variable 2 data is normally distributed. And you can see from the histogram images, if I plot a curve on this histogram from element I can go show distribution curve normal, and yeah, you see from here that data is not normally distributed for variable on. And if I go to the histogram of the variable 2 and put the same curve here, show normal distribution curve, and from the curve you also can see that the data is how the bell-shaped curve is formed here, and this curve, and look at this curve. So from here we can conclude that out of my two variable 1 and 2, variable 1 is not normally distributed and variable 2 is normally distributed. So thank you very much.